What's up, Earth Science Gang? Alright, today we're going to be doing an experiment where we melt down some phenylsilicetate. We're going to melt this in warm water, and then we're going to recrystallize it to demonstrate how magma recrystallizes it and how it recrystallizes. Alrighty, let's see what we're going to do here. So, on my right, I have some water. I heated it in my thermometer up to 100 degrees Celsius, and then I'm going to cool them in 3 different stations. I'm going to recrystallize on a cold station, I'm going to recrystallize at a room temperature station, and I'm going to recrystallize on a heated station. As you can see, that's all condensation from the heat. What we're going to analyze is the speed of recrystallization and what the recrystallization process actually looks like. So, let's take a look. Let's start to melt one of our vials of phenylacetylate. So what I did here is I put one of the vials in this heated water. So the melting temperature of phenylacetate is pretty low. So it's going to melt in this heated glass. As we can see, that's all melted phenylacetate in there. So what I'm going to do is I'm going to take a dropper of this, and I'm going to put it on our cold sample. Where's my dropper? Get my dropper. So let's watch what happens as it forms. It's seeming to already have starting to crystallize. Look what those crystals look like. Alright class, what do you think? That looks like it's pretty fully crystallized, right? I'll take a high definition picture after this and send it so we can actually analyze what those crystals really look like. It's really hard to tell. But as we can see, they kind of formed in different clumps. Like we have a clump right here, a clump right over here, a clump right over here, and if I hit it, it's solid crystal, like it's not breaking apart. And they're really finely made. So, that was under a cold sample. Now let's see what will happen at room temperature. I'm going to melt it down again. Give it a second to melt. Might have to plug this back in and reheat this water. See what the temperature's at. Yeah, the water temperature's right at 55 degrees Celsius, so it's about where we want it. So I'm going to try to keep the water at that temperature. So I'm going to continually unplug it, replug that back in on the heater, so we can make sure our water continues to stay at the right temperature. Plug there. Well, that's pretty melted. What do you think? was solid crystals. Now it's pretty melted. Now we're going to analyze what happens when we basically crystallize it at room temperature and what the crystals end up looking like. Different. Might just pour it out. So it started with one little chunk in there, but that shouldn't matter for our purposes. Let's watch us crystallize. Now, what do you think? Will it take longer or shorter to crystallize in the room temperature? Think of reasons why. Oh, it looks like it's starting to crystallize there. So those little blocks are starting to form around it. We're going to analyze how quickly this thing crystallizes, and I'll try to take a picture of them. But I can just tell you from an eye test right now, looking at the two various crystals that are forming, these crystals are much more in depth. They're much more structured than the ones on the cold plate. So these warmer crystals are much more structured. Take note of that. And we're gonna talk about and analyze why they might be more structured. Has to do with a lot of things, mainly with the chemical crystallization process. You know, chemical crystallization takes energy. And so when you have more energy out in the system, it might take longer to process a specific type of chemical reaction, such as crystallization. And so the same thing occurs in rock systems. You know, all that magma has to crystallize into the rocks that we look at for igneous rocks. Let's take a look and see if it's fully crystallized yet. Oh yeah. So that thing has been fully crystallized for a while now. These are just really clear. If we take a look, it's just really hard to see on this camera, but the crystals are more spread out, they're more defined, and here's in the quick moving the cold process crystals. Immediate, it looks like spider webs compared to more specific crystalline formations. Now, let's see what the crystal look like when we heat it up in a hot situation. Got my last test tube, phenyl acetate.